So hello and welcome to another video from sickmaths.co.uk, where you can find lots of free maths videos, and this video is for the Mechanics 1 module in A-level maths under the Elixir syllabus, and it's about limiting equilibrium, which means when the forces are about to move out of equilibrium. Equilibrium just means when forces are balanced, so we're about to move out of this balanced state. Now the thing that kind of pushes particle in or out of this balanced state is friction. So I'm going to explain this idea of limiting equilibrium and friction being applied in various amounts. To begin with, if you've got a block on a really rough surface, okay, and you're not trying to even move the particle or the block, okay, even if there's 0 newtons, we're not talking about this 4 newtons here, there's 0 newtons of force pushing at the moment, okay, there will be no frictional force, because frictional force only comes into existence when it's moving against something, when you're trying to move the particle or the block. I keep saying particle because that's the standard thing to say. We say particles, don't we, just to keep these questions really simple. Anyway, so you've got this block which has got no frictional force when you're not moving it at all or trying to even move it, but when you try to apply a 4 newtons amounts of force to move it, okay, and the maximum frictional force you can get from this rough surface on the block is 7 newtons, what you get is actually 4 newtons of frictional force, not 7 newtons. Because what it is, as I said earlier on, just a second ago, frictional force is like a counteracting force really. It's only a balancing force. So if you got 4 newtons of force there, you can get up to 7 newtons of force going the other way, but it only balances with the amount of force going that way. So you're actually only going to get 4 newtons of force to balance it. But when you get to say 8 newtons of force, then the particle will move because it goes beyond the maximum frictional force. Now limiting equilibrium is when you've got 7 newtons of force this way and 7 newtons of force, frictional force, the other way, because the maximum amount of frictional force is 7 newtons. So that's the idea behind that. So basically frictional force just balances the amount of forces trying to move it, but it can only balance it up to the amount of frictional force, the maximum frictional force that the object and the surface can create. So that's the idea there. And how do you work out the maximum frictional force? Basically it's mu r. Mu is the coefficient of friction, how rough the surface is basically, and the coefficient of friction between the surface and the object, I should say, because the object could be quite rough as well, okay, times the reaction force, okay, against the surface. The reaction force actually measures how much pressure you're putting onto the surface, because even if you had a really light object, you could push that object down and create more friction. So it depends, and the reaction force basically gives you the opposite but equal force applied to the surface. So you can see the reaction force goes away from the surface, but it actually equals how much force we're applying to the surface. So that's why mu r actually calculates, together they calculate the maximum frictional force. So let's do a question. So we're on the verge of rolling up. So as I might have mentioned before, the frictional force always goes in the opposite direction of the possible movement. So if we're about to roll up, that means the frictional force is going to go downwards. If we're about to roll down, the frictional force would have pushed upwards. Okay, and we're going to find mu, which is the coefficient of friction between the object or the particle and the surface. So first of all, we need to work out r, because that helps us work out the frictional force before we start going down the slope. So what is r? If you look at the trigonometry for mechanics video that I'll be making, it will tell you how very quickly to work out if you're going to use cos or sine. R is equal to the weight component perpendicular to the plane, or I should say the slope, okay, and also it's balancing with the a part of the 10 newtons, a component of the 10 newtons which is pushing it there, because it's also pushing it to some extent in this direction, because we're resolving this way, so we want how much of this 10 newtons force is going that way, how much of this weight is going that way. So how much of it? Well, if you look at the trigonometry video, you'll see that perpendicular to the slope means cos, so for the weight at least, so 2g cos 60 is balancing with the r, with also, well, since this angle here, this line is horizontal, which makes it parallel to this line, which basically gives you a z angle or alternate angle, which means this angle is 60 as well, this angle between this horizontal line and the slope. So if this is 60, you've got your right angle triangle here, like this, and the angle is there, and we want this component of it. That component of it is away from the angle. The angle is here. We're moving away from the angle. That means we're using 10 newtons sine 60. 10 sine 60 newtons. To say basically 10 sine 60 plus 2g cos 60 gives you balances with the reaction force that way. So as I've written here, R equals 2g cos 60 plus 10 sine 60, which equals g plus 5 root 3. Now how have I done that? Because I know sine 60 first of all is equal to root 3 over 2. Now root 3 over 2 times 10 is 5 root 3, because 10 divided by 2 is 5, times by root 3 is 5 root 3. So that's 5 root 3, and cos 60 is equal to half. Now again, this is in the trigonometry video, and there are examples of how to learn that very quickly. But cos 60 equals half, and half times 2g is 1g. So basically r equals g plus 5 root 3. Now this trigonometry video I'm talking about is in the Sick Maths website. On my, basically go into the A-level section for mechanics, and you'll see trigonometry for mechanics video, so that will explain all this stuff very quickly. Now going down the plane, now we're ready for it, because we were going to use a frictional force which is based on the reactional force. So now we know the reaction force, okay, we can go down the slope and use the frictional force, which will be coming up. So what are the forces going down the slope? Well, we've got only one force going up the slope, which is since we got 60 here, as we mentioned a short while ago, the force, what component of the force is going up the slope is going that direction. Basically you have to go through the angle. 10 newtons going through the angle gets you to cos 60, because through the angle means cos. So 10 cos 60 is going up the slope, which balances with 2g sine 60. If you look at the trigonometry video for mechanics, it tells you down the slope is sine 60 for the weight component. So 2g sine 60 plus the frictional force, which is also going down, and the frictional force is mu r. So mu times r, and r is equal to this stuff, which is over here. So that's that. So 10 cos 60, which is going up the slope, balances with the weight component going down the slope, plus the frictional force, which is also going down the slope. So if we rearrange that, basically you got 10 cos 60, take away 2g cos 60 divided by g plus 5 root 3, bringing it underneath, gives you this. 10 cos 60, by the way, is, we said earlier on, cos 60 is equal to half, so half times 10 is 5, so that's that 5. Take away 2g sine 60, which is basically g root 3, so take away g root 3 divided by this stuff equals 0.65. So the coefficient of friction mu is 0.65, and that's done. So let's also quickly explain this one over here. If we remove the 10 newtons of force, what happens? Will it still be in equilibrium? And what would happen? So let's look at all the forces. This force is no longer there, bear in mind, okay, because the 10 newtons force is removed and put as part of the question. Okay, so we've only got the weight force, and interestingly the frictional force now goes the other way because it's about to roll down. Obviously, if there's no force to push it upwards, why should it go upwards? There's only one force, which is on the particle, which is its own weight, so it's trying to push it down. So the frictional force is going the other way, so let's write that down. The maximum frictional force mu r is equal to the coefficient of friction, which we just worked out, 0.65, times the weight, the reaction force, which is 2g cos 60, which is basically, well, cos 60 equals half, yeah, so 2g cos 60 equals half times 2g, which equals just g, so basically you got 0.65 times g, which is 0.65 g. So the maximum frictional force which is going upwards is 0.65 g, and the weight force going down the plane, which is 2g sine 60, which is basically g root 3, which we worked out earlier on, because sine 60 is root 3 over 2. Root 3 over 2 times 2g is equal to g root 3, basically. So the weight force, root 3 is bigger than 0.65, so we got 0.65 g's and root 3 g's, so that is more than that. That means the weight force going down the plane is greater than the frictional force, and basically the weight force is more than the frictional force, which is keeping it from rolling down. So actually it doesn't keep it from rolling down, it actually does roll down, and that's it. The weight force is greater than the frictional force, therefore it must roll down, and that's